Welcome. Today, I'm covering right triangles and a unit circle. So you guys have, I think it's like 8 sections, some ridiculous number of sections, but I can simplify most of it down to 2 live sessions, believe it or not. So while yes, there's a lot of sections to cover, the material can be covered in 2 hours. So I'm pretty much combining most of chapter 4, some things in chapter 5 here, just kind of combining it all to a whole so you have what you need to know, the most important things. And it's going to be all about right triangles in this unit circle. So there's a lot of stuff that I would definitely recommend you have as notes and you have it handy. Some people suggest you memorize this stuff. I will be honest, I used to have it memorized. I use it so infrequently because I'm just not in a field where I use a lot of trig. When I was in electrical engineering, I had to use trig all the time. So that was when I had it memorized. But once I stopped doing engineering and I started doing just regular math, I don't use it as much. So I don't have it memorized anymore. But if you're going into engineering, you probably will once you get through it enough because you'll be doing so much of it. But in the meantime, definitely go ahead, have notes handy, whatever you need in order to get through this, and you'll start to memorize it as you use it more. Okay, so we're just going to start with a lot of definitions. So trig functions. There are 6 basic trig functions, and 3 of them are derived from the other 3. So we've got sine, cosine, and tangent. Those are the basic 3, and those form the saying SOHCAHTOA. The sine is opposite over hypotenuse, so that forms the SO. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. And that all comes from the right triangle. So if you have a right triangle, you have an hypotenuse, and then you have an angle, and one side's adjacent to that angle or opposite that angle. And so you can see the chart here, and SOHCAHTOA can help you remember how to figure out sine, cosine, and tangent. Cosecant is 1 over sine. Secant is 1 over cosine. I have a hard time remembering those, so I try to think, okay, the opposite of sine, 1 over sine, is the one that starts with C. And then the opposite of cosine is the one that starts with S. So that you don't, that's how I remember them. Then opposite of tangent is cotangent. That one makes perfect sense. Whoever came up with these should have called sine opposite over hypotenuse, and instead of cosecant, should have called that cosine, so that you could, they would go together. Another way some people do to think about it is if it doesn't have co in the name, then it needs something with a co. Sine doesn't have co, so it needs a cosecant. Cosine has a co, so it doesn't need one, so then it's secant. And then tangent doesn't have co, so then the reciprocal is cotangent. So that's one way to think about these things. Whichever works for you. I just wish they had named them a little better to make it a little easier to remember, but they didn't, so this is how it is. So you've got your 3 basic ones, and then you have the reciprocal of those. Okay, unit circle. So the unit circle has a radius of 1, or 1 unit, which is why it's called the unit circle. And the unit circle is used as the basis for pretty much all trig functions. Everything is done within the context of the unit circle. And once you understand that, it makes things start to make more sense, because basically trig, you're cycling, it's like you got a clock. You keep going around a clock over and over and over again. And so that's called the period, when you go through one full revolution, 360 degrees. And so trig functions they have a period where they start repeating. And so you're just kind of circling around about the unit circle. Now the tricky part is that the unit circle goes counterclockwise. So you're always going up and to the left. So you're heading towards the positive y and then the negatives versus a clock. So it's counterclockwise. So just keep that in mind. So how the trig functions relate to the unit circle. So I have a triangle here, a right triangle, and you can think of our horizontal, the adjacent side as x, and then the opposite side as y, because our x is horizontal, the y is vertical, and then the hypotenuse is 1, because the radius of the circle is 1. So with that basic unit circle, the fact that you have a radius of 1 and then you have your x and your y, from there you can determine trig functions. So based off of the unit circle, the sine of an angle is y, cosine is x, tangent is y over x. Then the cosecant is 1 over y, secant is 1 over x, cotangent is x over y. So if you have a right triangle and you know an x and a y, you can then use it with your right triangle. You can determine what the hypotenuse is. You can do a whole bunch of stuff. So now let's see how these connect. There are two special right triangles that you need to know that most trig is based off of. So the first is the 45, 45, 90 triangle. And so if you have a basis, you have a radius of 1, your hypotenuse is 1. So I have it drawn here so you can see that when you can draw a right triangle. So that's right here with the angle 45. And then as long as you look at your x and your y values, it forms a triangle. So that's the triangle we're looking at here. And so the x, that distance is a square root of 2 over 2. The y distance is square root of 2 over 2. And those come by looking at, let's pretend a different type of, different triangle. If you made the sides 1, then you can use the Pythagorean theorem to determine that the hypotenuse would be square root of 2. So then if you just divide everything by the square root of 2, you get a hypotenuse of 1, and then we rationalize to get square root of 2 over 2 because we don't like to have square root of 2 in the bottom of the denominator. So that's where that comes from. I would just try to memorize either the top triangle or the bottom one, whichever one makes more sense to you. And so we're moving counterclockwise, and if we look at our circle, 45 degrees, that is akin to pi over 4. So the circle is radians. Radians is another way to think about degrees. So a circle is 360 degrees, or we call it 2 pi radians. And so half of the circle, if you go from 1, 0 to negative 1, 0, that is pi. You have gone pi around the circle. Half of that, to go 90 degrees, is pi over 2. So 45 degrees is akin to pi over 4. So that's the radians angle. Pi over 4 is the same as 45 degrees. 90 degrees is pi over 2. So if you need to convert between radians and degrees, just remember the conversion factor that 2 pi equals 360 degrees, or pi equals 180. And you can always convert from one to the other. So I recommend remembering that conversion and then the triangle here. All right. Next, whoops, 30, 60, 90. So we have a 30, 60, 90 triangle, and that looks a little thinner. And this is also, you can see on the bottom left, that's where it comes from. If you had a triangle with two sides of 2, and then, if all sides it's equilateral, take it in half. That's how you can determine the angles. If you're using a radius of 1, then you've got 1/2 as one of the sides and square root of 3 over 2 is the other one, depending on if you're looking at the 60-degree angle or the 30-degree angle. So you have to think about which angle am I looking at to determine which one is the adjacent and which one is the opposite. 30 degrees matches with pi over 6. So I have that. You can see that it forms another, oops, I don't want to do that color of highlighter. That's no good. See, you can get another triangle here. So pi over 6 goes to 30 degrees. And if I had a 60 degree, so that is a terrible line, oh my goodness. Oops. 60 degrees is roughly there. And that would be pi over 3. So the way I think about it is 60 degrees has pi over 3, 30 degrees pi over 6. The denominator is opposite of the number that you have in your degree. That's how it works for me. That's a really badly drawn triangle, but that's what a pi over 3 angle would look like. Pi over 3 is bigger than pi over 6. So again, just memorize that. This will all make much more sense once you see how this is all used. Right now, this is just a lot of definitions, just things to have for your reference. Okay, trig functions and their complements. So, right triangles and things, because you have right triangles, you can take complements. If you have 60 degrees, you can take the complement to get 30 degrees, but everything is in terms of 90 because one of the you have a right angle which is 90, so the other degrees is 90 degrees. So taking 90 degrees and subtracting an angle will give you the complement. And so if you look at a sine and you take the complement, you get cosine. The complement of cosine is sine. Complement of tangent is cotangent. Cotangent to tangent. Cosecant to secant, secant to cosecant. This stuff makes sense. Complement, co. This is the one thing that actually does make sense with the names. So if you have something in cosecant and you don't know how to work with it, you can convert it to secant using one of these formulas here. Okay, so the unit circle, it's best to just have a reference so that you can see the key angles, what they are in degrees and radians, and then their ordered pairs. And the ordered pairs, they're always sine and cosine. Cosine's the x, sine is the y. So let's say I have 120 degrees. Cosine of 120 degrees, let me just highlight this, is right here. So the cosine of 120 degrees is -1/2. I'm just reading that off the ordered pair. The sine of 120 degrees would be square root of 3 over 2. So if you have your unit circle here, then you can actually read everything off the unit circle and you can get your cosine and sine pretty easily. So having a printed unit circle, you don't have to use this one, you can just find one online on the internet, is a really good handy resource. And that also helps you knowing where all these angles are. Okay, so now that I've gone through all of that, let's actually do some problems so that you can see how all of this works. Okay, I'm going to put my tablet down just so that I can write flat here. Okay, so we've got evaluate if possible, sometimes you can't, the 6 trig functions, at t equals -2 pi over 3. Okay, so I always start by first drawing my unit circle so that I have an idea of what I'm looking at. So I'm not so great at drawing circles, but that's okay. It's not perfect. It doesn't have to be perfect. I just need to know, basically, I just need the basics of what it's going to look like. So negative here means you're going clockwise. So normally an angle goes counterclockwise. Negative means you go the opposite, you're going clockwise. So we're moving 2/3 over 3 in the opposite direction. So if you're not sure what that looks like, I mean, I can guess what it's going to be looking like, but what you can do to figure out the other angle is to take 2 pi minus 2 pi over 3 to figure out what that is actually equal to. So I'm going to just take my calculator, which works with fractions. And then I need to convert that. Okay, so that is equal to 4/3 pi. So it's pi plus 1/3. So pi is there, and this is 0. So we're going 1/3 past there. So we're roughly at this angle. This is what our angle is for -2 pi over 3. So I just found this, it's not the supplement because that's 180. I just did 2 pi plus whatever that is to find the other side of the angle essentially. And so that gave me 4/3 pi. Okay, so now I have an idea of where it is. And so now I can draw a triangle. And you always draw it in reference to the horizontal axis. So this angle is pi over 3 because we had 1/3 pi. We had pi plus 1/3 to get our 4/3. So that's pi over 3, which is equal to 60 degrees. So I've got a 30, 60, 90 triangle. So I'm going to just go back. So that's 60 degrees, 30 degrees, and then my right angle. Okay, so now I need to go back to my 30, 60, 90 triangle because I always use everything in terms of that triangle. So across from the 60 degrees is the square root of 3 over 2, and adjacent is 1/2. So I'm going to go back. So adjacent is 1/2. So this side is 1/2, and then this is square root of 3 over 2, and then this is 1. And now I have to take into account that it's on the unit circle, and it's in quadrant 3 where both are negative. So that's going to be -1/2 and a negative square root of 3 over 2. So if I just go back, if that's getting a little busy, I'll just fill in my other triangle there. Now that I have figured out my triangle and I have my triangle filled in, now I can find the trig functions. So I'm going to start with sine. Sine, why does not want to write? Why is my n disappearing? There we go. Sine of t, that's our angle. So sine is always equal to the y value. So I'm going to go back. We're going to go back to here. Sine is the y value. Cosine is the x value. And then tangent is y over x. So you can go use your x and y base now that you have your triangle. Otherwise, you can have your SOHCAHTOA. So a sine, you can think of as opposite over adjacent, which is, or no, not opposite over adjacent, that's tangent. Opposite over hypotenuse. Opposite is square root of 3 over 2, or negative square root of 3 over 2 over 1. Or that's the y value. So sine of t is negative square root of 3 over 2. And then cosine, if it will let me draw it, cosine of t is the x value, which is -1/2. That is our horizontal distance. So now let's just do cosecant, which is 1 over sine. So that would be -2 over the square root of 3. But we want to rationalize it. So we're going to multiply by the square root of 3 over the square root of 3, which gives us -2 square root of 3 over 3. Now, 1 over cosine is secant, so secant of t is going to be the reciprocal, so that's going to be -2. That one's easy enough. And now tangent is opposite over adjacent. So the opposite angle is negative square root of 3 over 2 over -1/2. So this will simplify. The negatives cancel. Their denominators essentially cancel, and you're just left with the square root of 3, which means that cotangent is 1 over the square root of 3 because that's the reciprocal, which we rationalize to square root of 3 over 3. So first I draw my unit circle to figure out where my angle is. Then I draw my triangle. And once I determine my triangle and fill in my triangle, then I fill in the 6 trig functions. This is how I do it. There may be another method that works for you. This is what works for me. Okay, so now we've got another example here. Find the exact values of the 6 trig functions of angle theta. So they're giving us a right triangle here. And so we need to figure out the missing side before we can go further, before we can find the trig functions. So let's just label that x, since that is horizontal. So I'm going to use the Pythagorean theorem, which is a squared plus b squared equals c squared. So x squared plus 4 squared equals 8 squared. So x squared plus 16 equals 64. And then I'm going to subtract 16. X squared equals 48. So now I'm going to take the square root of both sides. We're going to use the positive answer because distance is positive. If we had an angle and we knew where it was on the unit circle, we might have the negative answer, but in this case we don't know, so we're going to assume the positive. So we have the square root of 48, which is, let's see, that's 16 times 3, which is 4 square root of 3. So that's our missing side, 4 square root of 3. So if you weren't so good at simplifying radicals in college algebra, you're going to have to do it here. So now that I have found the missing side, I can go through and find my trig functions. So I always start with sine, cosine, and then I think I can get all 3 on one side here. So sine of theta, so that's opposite over hypotenuse, so katoa. So I'll write that. So katoa. So the opposite of theta, opposite is 4 square root of 3, and the hypotenuse is 8. So that simplifies to square root of 3 over 2. Cosine of theta is adjacent over hypotenuse, so that's 4 over 8, so that's 1/2. Then tangent is opposite over adjacent, 4 square root of 3 over 4, which is square root of 3. So now I can do the reciprocal. So the reciprocal of sine is cosecant. So that would be 2 over the square root of 3, which we need to rationalize as 2 square root of 3 over 3. The reciprocal to cosine is secant. So that's 1 over 1/2. That's just 2. And then the reciprocal of tangent is cotangent. So that's 1 over the square root of 3, which rationalizes to the square root of 3 over 3. Now I've gotten all 6 values, all the exact values of trig functions. And actually, you may think, oh, these numbers are very familiar. Well, indeed they are, because this is a 30, 60, 90 triangle. So you can even then figure out the angle based off of what you got for your trig functions. But it's not asking us what the angle is, it just wants to know what the trig functions are. Okay, so now we've got another example here. Use the given function value and the trig identities. Those are the first things, those 6 rules, those are trig identities, to find the exact value of each indicated trig function. So they are telling us that cosecant is equal to 5. Cosecant is 1 over sine. So 1 over sine theta is equal to 5, which tells us that sine of theta equals 1 over 5. Take the reciprocal of both sides. So I know sine is 1 over 5. Okay. Now I need to find cotangent, tangent. I need to find these other things. And let's see, what do I know? I'm going to draw a unit circle. Or not a unit circle. A right triangle. So sine is opposite over the hypotenuse. So if the sine is 1/5, that means the opposite is 1 and the hypotenuse is 5. So with that, I can now use the Pythagorean theorem to find my missing side. So I have x squared plus 1 squared equals 5 squared. So that's x squared plus 1 equals 25. So x squared equals 24. And take the square root. Again, I don't know if there's negative, so I'm going to assume the positive. Let's see, how can I split? That's going to be 4 times 6, so that is 2 times the square root of 6. I know my missing side. 2 square root of 6. And now that allows me to find cotangent. And actually, it might be easier to find tangent first and then cotangent, because those are reciprocal. So tangent is the opposite over adjacent. That's TOA. So the opposite is 1. Adjacent is 2 square root of 6. And I need to rationalize. When I rationalize, I only need to rationalize the square root of 6 part. So I'm going to multiply the top and the bottom by the square root of 6, which gives me square root of 6 over 2 times 6, because square root of 6 times square root of 6 is 6. So I get square root of 6 over 12. Now the cotangent is the reciprocal, so that is equal to, and actually I'm going to take the reciprocal of my first thing, 1 over 2 times the square root of 6, and that gives me 2 times the square root of 6. Next is the secant. Secant 90 degrees minus theta. So let's go back to our complements here. Secant of 90 degrees minus theta is equal to cosecant of the angle. So this is equal to the cosecant of theta, which they tell us is 5. So that means the secant of 90 degrees minus theta is equal to 5. So now, using just one trig function that they gave us, we were able to fill in the entire right triangle and fill in and be able to figure out all the other trig functions. Doesn't matter what the angle is. We don't need to know the angle. We can do everything with the right triangle here. Okay, so now, this is a different type of problem. The point 3, -4 is on the terminal side of an angle in standard position. Terminal side means that it's going to be in reference to the horizontal. Find the exact values of the 6 trig functions of the angle. So I'm going to draw, and then we've got 3, -4. So 3, -4 is about here. So that's 3. This is -4. And terminal side means the angle is going to be in reference to the horizontal. So you could have 2 possible angles there, 2 possible ways you can draw that triangle. We're going to use the one in reference to the horizontal. That's the terminal side. So I've got one side is 3, the other side here is 4. And we need to find out the hypotenuse. So you can use the Pythagorean theorem, or if you remember anything about right triangles, there's a right triangle, 3, 4, 5 right triangle. That's one of the few things, I think that's the only one that I remember from geometry in high school, is 3, 4, 5. So that means the hypotenuse is 5. So now that I've got my triangle here, I can determine the 6 trig functions. So sine of theta is the opposite over the hypotenuse. See, I Sometimes I think of it in terms of X and Y. Sometimes I think of it in terms of triangles. It depends on where I'm at. Here I didn't draw a circle, so for me it's easier to do opposite of hypotenuse. So the opposite of my angle is -4, and my hypotenuse is 5. So the sine of theta is -4/5. And the reason why I couldn't just use the y value here is because the radius is not 1. So that only works if you're on the unit circle. I'm not on the unit circle here. I could have tried to figure it out that way and said, okay, I got to multiply my sine by whatever, but I'm just going to do the right triangle. So cosine is ca adjacent over hypotenuse. So the adjacent side of my angle is 3, hypotenuse is 5, so that's 3/5. And then the tangent is the opposite over adjacent. So that's -4/3. And now I find the reciprocal. So the reciprocal sign of cos is cosecant. So that's going to be 5/-4. The reciprocal of cosine is secant. So that's 5/3. And then the reciprocal of tangent is cotangent, which is 3/-4. Once you have your triangle or your unit circle, everything flows very nicely from there. It just goes, it just works. It just works. That's all you need to know. So that's it. That was basically the basics in a nutshell. I was able to get through that in half an hour. That's like the basics of all the identities you need to know and how to find angles. We haven't found angles yet. We haven't really found theta. That's going to be in my next session. But these are the basics of using the right triangle in reference to the unit circle and figuring out trig functions without even needing to use a calculator at all to get your angles. So I have another session. Well, where is my calendar? Because I know I have another one. I think it's tomorrow. Tomorrow at 1 p.m. On trig identities and solving trig equations. So that's where we're going to actually be finding angles. And let me just talk briefly about the assignment. Now that, let's see, Blackboard should be back up. So it wasn't up before. It was down for about an hour. So let me pull up the assignment. Because I'm going to I mentioned this in my introduction about the first question to show all your work, and okay, the pictures are showing up. First one's difficult. You don't need to use any trig functions for that, just as an FYI. And number 2, you don't need a trig function. And then for 3, you're drawing a right triangle. So everything I did today, you can use for 3. 4. You can do most of 4 with everything you know today. And then 5 is just basically plugging stuff into a calculator. So, yeah. So it's pretty much, you should be good for quite a bit of the assignment. 1 and 2, those are based off of number 1 I did by unit conversion, essentially, or ratios. Some people use it with the S equals R theta. I don't do it that way. I just do unit conversions, and I convert, well, my diameter on this moves this much on here. So I just do it by unit conversions. I don't even need to use trig for that one, but you can do it with trig. Number 2, there's a formula for that. So you should have everything you need to do most of the assignment already, but it's good to know how to solve for thetas. So that's going to be tomorrow at 1 p.m. So hopefully I will see you guys then. And hopefully this wasn't too confusing for you. A lot of it is just references and just like going back to your references and just working through and seeing what you know. So that is it. I will see you guys tomorrow. Bye. Where's my mouse?